Today we're going to be wrapping up nutrient management planning. So hopefully by next week, people will be handing in their plans and we'll be reviewing them and making sure they're completed and completing the whole process. But I did want to touch base today to start on potassium because we haven't covered potassium yet. And if we're not dragging on too much, I'll try to cover some of the micronutrients too. But potassium, at least in Vermont, is always a nutrient that is limited and very limited in some soil types. Especially the river bottom soils and up in the like uplands, kind of in the hill country of Vermont, we see a lot of potassium deficiencies. I feel like often potassium gets, like potassium deficiencies often get misdiagnosed as nitrogen deficiencies. And people just don't seem to pay the same attention to it as they do nitrogen. And, especially at the end of the season, we can see potassium run out. It's pretty common to see deficiencies a lot of the times in corn plants and cornfields, especially along the rivers. And like I said, up in some of the upland soils. So managing potassium, it is a macronutrient. The crops use a lot of it. And if you are deficient in potassium, again, it needs to be recognized and reconciled too, because, minimizing or not having enough potassium really greatly impacts so many of the other nutrients. And of course, your plants need potassium too. So we want to make sure we take care of those deficiencies. So the potassium cycle is far less complicated than the nitrogen cycle that we went through last week, but we do still see a lot of potassium that gets fixed, especially if you have clay soils or really heavy clay soils. You can get potassium that gets fixed, like sort of between the layers of clay. If you have a heavy clay soil and you've added quite a bit of manure over the years, oftentimes the potassium levels can be off the charts in those soils that are higher in clay, because the potassium does get kind of bound up, like I said, between the layers of clay. It does eventually become available, but it does move more slowly than exchangeable potassium. So exchangeable potassium, if you remember from our talk about cation exchange capacity, is the potassium that is attracted to the negative charge on the clays, which is different than the potassium that gets fixed in between the clay soils. So exchangeable potassium does move onto and off from those exchange sites pretty easily because it only has that one plus. Remember that from last week? So it's easily moved off the exchange sites into the soil solution. And usually there's kind of a pull, like once plants start to take up the potassium or potassium gets lost through leaching, potassium will move easily off of those exchange sites and try to keep things in balance. But of course, if there isn't enough potassium to go around, that can cause issues. So it's a pretty simple nutrient cycle, but there are a few nuances here. One being that even though it's K plus and it can hang on to the soil or be attracted to the clay particles, it's held very loosely. So it's also very prone to leaching in certain soil types. So that's just something to think about. And we have to think about it when we're adding potassium. So if your soil test says you have a really high need for potassium, let's say the recommendations for 200 pounds, you don't want to put all that on at one time for a couple of reasons. One is that your plants will luxury consume it, but also it can be very prone to leaching. So you're best off to apply potassium in split applications, especially if you need a lot of it. Okay, so again, this is just showing some of those different forms of potassium. So we have primary minerals, And of course, over time through weathering, we get the release of potassium. We have these 2-to-1 clays, we call it, where that's where you have the potassium that's stuck between the clay layers. It does move out of those areas, but it's very, very slow. And then you have exchangeable potassium. And again, that's the potassium that kind of hangs on to the negative charges on clays and organic matters. And that moves off of those sites pretty readily into the soil solution that then can be taken up by the plant roots. As I said, potassium deficiencies are really common in Vermont, and I would say that especially in corn crops and also legume crops, we see potassium deficiencies quite regularly. So again, if you get your soil test back and it says that you need potassium, you really should be thinking about how you're going to add that in fertilizer from manure. Okay, so the balance of potassium is also really, really important to the balance of other nutrients in other cations. So you remember the cations are calcium, magnesium, and potassium. And hopefully you remember when we were looking at the soil tests, we were showing this ratio of those nutrients, like how much calcium to potassium to magnesium. And that is really, really important in the soil, but also really important with our livestock and managing certain metabolic disorders that involve the imbalance of those cations. And so if we're deficient in potassium, and we have excess amounts of magnesium, let's say, I'm sorry, if we have excess amounts of potassium and not enough magnesium, our animals can actually become sick because they're not getting enough magnesium from the forages that they're being fed, and same with calcium. And so we get metabolic disorders basically that, can start in the soil, move into the plants, and then cause issues in our animals. A lot of the times we get high potassium feed, and that means we have low calcium and low magnesium in the feeds, which translates into some of these metabolic disorders. All right, so managing potassium and legumes, and I use alfalfa as an example here. So alfalfa uses a lot of potassium, and legumes in general use much more potassium for different reasons. So, in the case of alfalfa, potassium is really, really important to reducing winter injury in that crop. It helps sort of act like antifreeze in the winter time. So if you're growing alfalfa, you'll see really high recommendations. And alfalfa also removes a lot of potassium, which is why we have to replace it when we harvest. The nice thing, of course, is if you have a lot of potassium from years where you've been growing corn and adding a lot of manure, if you grow alfalfa following that, you'll draw those levels down quite easily. So if you're managing alfalfa, you need to make sure that you're checking the potassium levels in the soil regularly, and adding back what that crop needs, because it's critical to the longevity of the stand. So when we're talking about grasses, grasses also remove a lot of potassium, and grasses are far more competitive for potassium than legumes. Okay, so if you're trying to have a mixed stand of legumes and grass, and you start to see the legumes kind of go away, you should definitely be looking at the potassium levels of the soil as well as the pH. So legumes need a lot of potassium and they need a high pH. And oftentimes, in our soils, we can be limited in both. So if you're growing a mixed stand with grasses and legumes, and you're low in potassium to begin with, the grasses are going to be much better at scavenging what is there, far better than the legumes. So if you're trying to keep a mixed stand, you really need to make sure that you're providing the recommended amount of potassium, because otherwise the grasses are definitely going to be able to dominate the system because they're, you know, better able to compete for the potassium that's there. All right. So we like to use potassium as a way to show different approaches to fertilization. And potassium is, as I mentioned before, a nutrient that plants will luxury consume. And they don't do this with other nutrients, but they do it with potassium. And so using or talking about these different fertilization approaches when we're referring to potassium is really critical because of the nature of that nutrient. So there's 3 different approaches that people use generally. We didn't put the shotgun approach here, but 3 approaches that people use to applying fertilizers. So one is called the sufficiency approach, which is based on maintaining soil test level, right? So when we were looking at the soil test, if you have a low level of potassium, or a medium, or optimum, or high, the recommendation for that nutrient is based on reaching that optimum level, right? So it's trying to add potassium based on what's already in the soil and reaching that optimum level. And that's called the sufficiency approach. Then there's the maintenance approach, which some people use, and this is based on the replacement value of nutrients removed by the crop, okay? And so the maintenance approach does not look at soil tests. It actually just says, I am growing, 4 tons of dry matter hay crop, and in every ton, there's this many pounds of potassium that I am removing from the field. So when I apply fertilizer, I'm going to put that much back. And that's called the maintenance approach. And, it doesn't value anything that's already in the soil. And then we have a soil cation balance approach, which we talked about a little bit when we were reviewing soil tests, where we look at the base saturation of calcium, magnesium, and potassium in the soil, and we make recommendations or add fertilizers to maintain those ratios. So these 3 different approaches, have positives and negatives, but the best approach is to use a combination of all of these. And that's what we do through, our UVM recommendations, depending on the nutrient, of course. So we look at what's in the soil, and we look at yields. And then we also look at the cation balance, especially for potassium, and we base a recommendation on those 3 approaches. So with the UVM test, we're looking at all 3. Now, just to use one or the other, again, like I said, it can be, there are more challenges than benefits if you're just using one of these. So you can see how using the maintenance approach can actually get really expensive because you're not valuing anything in the soil. And using the soil cation approach actually misses a bunch of nutrients. And the sufficiency approach is great, but it also doesn't, it doesn't take into account cost. So if you're just trying to reach an optimum level and you're low, you can be having to put on a lot of nutrients and not be able to afford that. So using a combination of that with other approaches can be really beneficial. Okay. Let's skip over that. I already talked about that. Oh, so as I mentioned before, potassium is one of the only nutrients that plants will luxury consume, which means, you know, if they have enough to function and meet all of the critical functions that are required for potassium, most plants stop taking up that nutrient. Otherwise, you know, in some cases, certain nutrients at high levels can, you know, be very toxic to the plant. So the plant does, you know generally enough is enough. But with the case of potassium, that's not at all true. So it will actually, if there's excess potassium, it will take up more than what it needs. And this is where we can run into some issues with these, you know, metabolic problems where the plant is actually taking up way too much potassium at the expense of other nutrients. And those nutrients being calcium, magnesium, and also nitrogen, okay? So balancing potassium in the soil is really, really important. You don't just want to put on a slug of it because the plant will just keep taking it up. It won't say, well, I'll, you know, take up this much, and then when they take another cut, I'll take up some more to regrow. It doesn't work that way. Okay, so again, because the plants luxury consume, you want to make sure to be really cautious about what you put on and when. So I'm not probably going to spend much time on this, but this is one of the reasons we don't use a replacement value for potassium, is because we'll end up likely over applying that nutrient because, again, it'll take up more than what it needs. And so if it only needed 2% and it took up 3%, and you're replacing exactly that 3%, you're just adding too much potassium. Okay, so potassium is a relatively easy nutrient to purchase if you don't have manure on your farm. It comes in a lot of different forms, both organic and conventional forms of potassium are widely available. The most common form is muriate of potash, 0062 or 0060. And there is an organic form of a very, very similar formulation, which is 0052. So it's relatively easy to find potassium sources that are both organic and conventional. Oh, I'm going to go back here. One of the sources of potassium that has gained a lot of popularity in Vermont and New England in general is wood ash. I get asked about wood ash a lot, and wood ash is, you know, it's burnt wood. So whatever wasn't burned off, like the carbon is burned off, it's all the nutrients that are left over. And there's quite a high level of potassium in wood ash. There's also calcium. There's also a little tiny bit of phosphorus, but a lot of micronutrients. So wood ash can be relatively high in boron and molybdenum and potassium. So if you're looking kind of for a complete legume fertilizer, wood ash is a great one because it includes all of the things that legumes really need to grow and thrive, which is calcium, potassium, and molybdenum and boron. So I always hear from different farmers that say, oh, I use wood ash, and oh, you wouldn't believe the clover after that. And that's why, because when you apply wood ash, you're basically giving the legumes a real nice complete fertilizer package. So if you have low pH and you need calcium, you also have low potassium, and you're growing a good amount of legumes, that is definitely a great choice if you can get it and get it spread. All right, so split applications of potassium are really important, again, because we don't want to have luxury consumption. So if you need a high rate of potassium, you want to make sure you split up those applications, you know, and apply that potassium, not putting it on in totality. Okay, it also helps reduce leaching losses too. As I said, potassium can be very prone to leaching depending on the soil type. So making sure that you split those applications is really important. Okay. I will say normally we want to put potassium on after first cut. And the reason I say that is because in the springtime, we get kind of a flush of potassium into the soil solution off of the binding sites. And so potassium levels are generally at their highest in the spring. And so, you know, if you do need to put on potassium, generally waiting until after second and after third is going to be the best time to put it on. Okay, when you lime, or if you need to lime, what basically happens is that you kind of increase the exchange sites and you end up with more exchangeable potassium. So you can see more potassium after liming. And liming can also help reduce potassium leaching because you've opened up by talking about potassium tends to sort of, I think, the water, the freeze cycles, but you get a lot of free potassium in the spring ready for plants to take up. And that really coincides with the levels in our forages. So we see usually the highest levels of potassium in first cut, especially if it's cut early. And then those levels go down in our forages, potassium levels, you know, from a feeding perspective on the farm, usually our first cut will be highest, and then the levels of potassium in the feed go down again over time. So just to make a quick note as well, so you notice we talked about this a few slides ago, but if you look to the left under May, you can see when potassium uptake is the highest, you also see a decline of calcium, sodium, and magnesium uptake too, right? So when you have a lot of potassium, it will outcompete the other nutrients to move up into your plant. So this is where you might have some issues, you know, herd health issues, especially in the spring. You know, when you put the cows out to pasture and you end up with grass tetany, a lot of that has to do with, again, having that flush of potassium in the spring and very low levels of magnesium as a result of that being taken up into the plants. All right. So this is just, you know, showing very similar data where we're on the bottom axis, you can see different levels of potassium added to the soil and the impact that that has on the other nutrients being taken up into the plant. Okay, so again, managing potassium is really important as far as impacting these other nutrients and, you know, producing forage that is balanced. Okay, so potassium also has a heavy influence on nitrogen uptake into the plant. And I find that, as I guess I was mentioning before, a lot of people will pay attention to nitrogen, but they don't pay attention to the potassium needs of the soil. Everybody is worried about nitrogen. So if you have low nitrogen levels, but you're putting on a bunch of nitrogen fertilizer, you can see the yield response. That's on the bottom line. Here, it's the lowest line where it says 0 kilograms per hectare of potassium was added. And you can see all the nitrogen that was added, and you don't really get a yield response, right? But if you add nitrogen and potassium and you're meeting both of the needs, then you see the yield response go up. So taking care of one nutrient deficiency and not another doesn't mean that you're going to end up with a visible difference in your crops, right? So early on, we were talking about soil tests. We were talking about, oh, if it's low and you add it, you're going to see a response, which is probably true. But if you're also low in phosphorus and nitrogen, and you add only one of those, you may not see a response at all. And so trying to take care of all of the different nutrients in the soil is the best approach, not just sinking all of your money into one. All right, so a lot of people, again, deal with high potassium forages and impacts on their animals. And so they're constantly trying to battle high levels of potassium. And as I mentioned before, it's a nutrient that crops luxury consume. And if you know that, then you can work on managing that throughout the season. There's other, things, as I mentioned, that can be managed. The more mature crop, really the less kind of quantity of potassium you'll have. And then, of course, the time of the year, as I mentioned, as we go further into the season, the levels of potassium go down through leaching or drawdown of some type. All right. So the normal range that we're looking for the different crops is shown here. And again, just managing that is really critical, especially on livestock operations. Different species of grass don't vary all that much, but you can see, species like orchard grass can definitely end up with higher levels of potassium than some of the other species. I don't really know anybody that manages grass species because of potassium, and, it doesn't make that huge of a difference anyway. I think the biggest thing is looking at your soil test, managing those harvest timing, and if you need potassium, making sure that you're adding that in split applications over time. All right, I think that's about it for potassium. Also, nutrients, and then we'll get into the last pieces of your homework. So as I mentioned before, micronutrients and secondary nutrients, but micronutrients in general are needed in really small amounts. They're still critical to plant function and productivity, but usually we're adding these in pounds, not hundreds of pounds. And that's really important because the level between like not enough and too much is pretty fine. So following recommendations, is, especially important in these cases because these can be very toxic to the plants and animals too if they're not applied properly. All right, so we already talked about, macro versus micronutrients. These nutrients have charge as well, just like, the other nutrients we've been talking about. So you can see boron's on the top. These are the nutrient forms that your crops would take up. You can see boron has a negative charge, and so doesn't molybdenum. So they're really easily lost from our soil system. And part of the reason why they're commonly recommended in the state of Vermont, especially boron. And again, boron and molybdenum are very, very important to legume production, which is why we commonly recommend boron in Vermont, because it does leach and it's commonly deficient. The other nutrients do hang on to the soil relatively loosely as well. But again, boron and molybdenum and also zinc, and manganese, I guess, too, have been deficient in Vermont soils and reported in the past. So they are things that we look at.
Hey, Heather.
On the soil.
No, Heather, can you hear me?
Maybe do it in chat.
Heather, the audio is skipping out a bit, and so is the video. I'm wondering if turning off your camera might help. Camera today. Turn off our video too. I hope.
Oh, hey, Lindsay.
Hey, we can hear you.
Yeah, sorry about that. I don't know what happened. But I'll try to get through this fast and then we'll,
Thanks.
yeah, I don't know what happened, but oops, I have good internet. Okay. So I was talking about the micronutrients and I just, I feel like we don't ever really give them enough time and they can be deficient in Vermont soils. And we, I've seen this over the years, but there are some clear, would say, situations where, you definitely want to pay attention to the micronutrients. And I'll talk about those here in a minute. But here are some different crops and different micronutrients that they have high requirements for. So as I had mentioned before, boron, alfalfa has a very high requirement for boron. And you can see, same with like pastures that have legumes or grass fields, hay fields that have legumes in it. They have a high affinity for boron. Manganese, again, high requirements in certain crops. Zinc, corn has a very high requirement for zinc, and we do give recommendations commonly in Vermont for zinc. And molybdenum, again, you can see high requirements in some of our legume crops, and then copper requirements are high in some of the vegetable crops. So this is just a nice table, I think, that kind of points out crops, individual crops that have high requirements for certain micronutrients. And just like all the nutrients we've talked about, they're really critical for different processes in our crops. But again, the sort of difference between sufficiency and toxicity is really small. So again, just paying close attention to applying exactly what's needed and not thinking more is better is really important here. Okay, so diagnosing micronutrients deficiencies, usually, to be honest, when I have seen some of these, like molybdenum as an example, and manganese deficiencies, it's been too late by the time, I get called out. There's something weird happening, so you finally get a call and you go out there and you figure out what it is. Not that it's always too late. Usually at that point, you have to put on a foliar fertilizer. But, we can diagnose some things like through soil testing, like I said, especially boron, zinc, manganese. But usually the other micronutrients, you need a tissue test, plant analysis to really understand if they're deficient. And I'm sure if you've ever looked on the internet, and you're trying to figure out what's wrong with your plant, everything starts to look the same. A disease symptom and a zinc deficiency or magnesium. So sometimes it's just really hard to diagnose and you do need to send in a plant tissue sample. All right, so again, when do you want to actually apply micronutrients? And so if we know the crop requirement is high, and we know the soil test is low, usually that is, a place where we would want to add a small amount of micronutrients. Okay, I already talked about that. Okay, so other conditions where we see micronutrient deficiencies that you should be on the lookout for are in very sandy soils that have low organic matter. And have really no history of organic matter additions or very limited, we would generally likely see micronutrient deficiencies. And those would be places where you should be adding like a micronutrient pack. And then sometimes, as you know, we talked about before, depending on the soil pH, you can have micronutrient deficiencies or excesses as well. Yeah, okay. All right, so here's some photographs. And again, I think it's hard because, you know, these things, they look like a lot of other things too, but some pretty pictures just really showing magnesium deficiency, which we do see in Vermont. Oftentimes it's when potassium levels are really, really high or excessive. So, you know, again, managing that is important. Already talked about this stuff, so I'll skip over that. Sulfur deficiencies, we have observed these in Vermont. Sulfur is not a micronutrient, it's a macronutrient, but we do and have seen deficiencies, again, especially in really sandy soils that don't really get any organic matter additions, and when we've had a lot of rain. So, you know, these are things in some of those soil types we should definitely be looking at this year. Okay. Skip over these things. Zinc deficiency is also, you know, it's a real issue in Vermont. We see this often. You do get a zinc measurement on your soil test, and you can make a zinc recommendation from those numbers. So we do see zinc deficiencies, you know, when we have cool weather, low manure applications, and, you know, if the pH is really high, and oftentimes when phosphorus is really high as well. So again, this is a nutrient that folks will want to pay attention to, especially if they're growing corn. All right. So we talked about this. Boron, I would say for most people, this is really common. You've probably seen legumes, not just alfalfa, but clover that has that reddening on the outside, kind of the margins of the leaves. And we see this a lot. Boron, like I said, it leaches really easily and is a real problem in certain crops, you know, especially legumes. So most soil tests come with a boron recommendation. Okay. Here's another picture. One of the problems that we do have in Vermont, and so we have gotten misdiagnosis before, is that in a year where we have high leafhopper populations, not every year, leafhoppers cause injury to legumes, and you can see an example of that on the bottom, where you get this sort of yellowing V shape on the tips of alfalfa and different clovers, and that's caused by an insect. Not by boron deficiency. And believe me, you'll know if you have really bad leafhoppers, you can pick it out pretty clearly in a field. Usually a boron deficiency is pretty centralized. You can just see a little patch, maybe here and there, but if you have a bad case of leafhoppers, it'll be the whole field. All right. Manganese, again, the only time I've really seen this is in soybeans. And I've seen it on clay soils mostly. And I've only seen it a few times, you know, in my career here, but it has been a problem down in Addison County on heavy clays, especially in soybeans. So again, you know, here's a picture of that. You can also see this in small grains. I haven't seen that myself, but I've definitely seen this as an issue in soybeans. So with more soybeans being grown, definitely should be on the lookout for these types of deficiencies. And this is a pretty extreme case in snap beans. All right. All right, so there's lots of other micronutrients as well. Again, there are conditions where we might suspect that there's a micronutrient deficiency. Again, if the pH is on kind of either end of the extreme, I'm seeing a lead issue now in some samples that were recently sent to me, and it really has to do with the pH of the soil. So the recommendation is improve the pH, and the amount of lead in the plants will go down substantially. So again, managing pH is a really important, and again, if you're on really sandy soils, that haven't had much organic matter addition at all, depending on the crop you're growing, you could be at a much greater risk for nutrient deficiency in general. Okay, I think I will wrap it up there, and we'll get into the final pieces of, not really homework. You should be done with all of your Go Crop data entry, hopefully. But we do have a few final pieces that I want to go over. I can get back there. So just give me a second here. Get out of there. Let me go here. All right. All right. Okay. So today I want to go through the pieces of the plan. So over the last few weeks, you've been adding all your data into Go Crop, one little piece at a time. And what that should be producing is the nutrient management plan, which you haven't actually seen yet. You haven't seen the pieces of that unless you've been kind of poking around. And so to actually start to see the forms of the plan, so the data that you've put in actually populated into the forms that will make up your nutrient management plan, you need to go to this little paper here, which is reporting tools. Okay, I think if you go, no, there you go. Okay, so you go to the reporting tools tab, and then what you're going to want to do is go to your plan. So it's January 10th, 2024, and hit the blue ... button. Okay. So these are all the different reports that you will need, and we'll be printing these out, reviewing and printing them out, to complete your plan. So again, this is all the data you've been entering that has been put into these different forms that are the requirements of the plan. Okay, so I'm just gonna go through most of these so that you can see what they look like. Now, when you start opening these up yourself, if it doesn't open, it'll say so many seconds. But if it doesn't open or there's an error, it means that it's missing something. Okay, it means that you haven't put in all the data that is needed. So let's open up farm summary. Okay, so you can see it says generating report pending. And if everything is in, okay, it will generate the farm information report. And this is the first page of your nutrient management plan. So if everything got filled out, okay, should be on here. All right, so that looks complete. The other forms are all listed here. So every one of these, really, you'll need to open and check and make sure the data is there and everything is filled out. And then to the right here are all the individual fields. Okay, so you need both sections. You need these kind of farm reports, and then you need the field by field reports to complete the plan. And the easy thing to do, if you think you have everything finished, is hit combined report, and that will put all of these together into one PDF and open up. But if you're missing something, it won't do that. Okay, so if you can't form a combined report, somewhere in here, you're missing data. Okay. All right, so the second report that I want you to look at is the manure drawdown report. And this is one that I want everybody checking today, because this is a piece that's really important and has to be correct to sign off on your plan. And whoever's working with you, your technical service provider knows this, so hopefully they've already helped you with this. Okay, so the manure drawdown report lists the total amount of manure you had for spreading, okay, in the calendar year. And then it shows each field, okay, and the manure that you added to that field, okay, and then the amount of manure remaining. All right, so you can see I have 3 fields, and I have over 1 million gallons of liquid manure, and I have not added all of the 1.3 million gallons that I produce on my farm. Okay, I've added 1 point or less than 7,000, 14,000 gallons. So what you have to show in your plan in order for it to be approved is that you have spread all of the manure that you produce in a year's time on the fields on your farm. Okay, so once you've entered everything into the plan, last week you were entering manure amounts, right? How much manure you're putting on each field. So now if you open this up today, these numbers should be close to 0. Okay, they can be within 10% of the total, but they have to be, close to 0, plus or minus 10%. So you have to be able to show that for all the manure you're producing, it is being spread somewhere on your land base over a year's time. Now, if you export some manure, then you're going to have to record that in your plan. Okay, so if I have all this manure left and I say, well, the neighbor takes all of this, then you have to report that in your plan, and there's forms to do that. Okay, now if you open this up and you've spread 1 million gallons more than what you produce, either the amount that you produce is wrong in the plan, or you're not applying as much manure as you think. Okay, and so you got to go back and correct that. So you have to be able to show that all the manure that's produced on your farm in a year is used on your land base. Okay, so that is part of your homework today and into the next week. If that number is not close to 0, plus or minus 10%, you need to go back and add more or less manure to the fields so that it gets there. All right, so then there's a report that shows your manure sources and the nutrient value of the manure. There's a field inventory report. Pull that one up quick. This one lists all of your fields, acres, crops being grown. Okay, so here's the field inventory report. It shows your soil type, the Russell 2, the T value for the soil type, the rotation. It shows you your soil loss based on the rotation, and it shows you the year you are in your rotation, and it also shows you for that year what is the soil loss. Okay, it shows soil test levels and your P index. So this is a really useful report, but there can also be a lot of errors that we catch in here. So you want to open this up and make sure that the field behind the barn is actually in grass hay rotation, or you're in corn silage with winter cover crop. And if you're not in that rotation or not in that crop going into this year, you need to go back and fix that. Okay. It also has a spot here where how yield goals were determined. So that's where that information goes. And that's the field inventory report. Okay. The risk assessment outlines, a number of the different soil pieces and characteristics that we were looking at. And then there's the P index. Okay, so this one we tend to see a lot of errors in. You'll be trying to open this report and it might pop up that, there's missing information. It gives you a little bit of information about where or what, if it's not complete. So you'll have to go back and, fill in the blanks if it doesn't populate. So if you remember from I think the second class, we talked about the P-index and we talked about that Excel spreadsheet. Well, this is that, right? So it's calculated the P-index for you and given you the interpretation, okay? So you can see here we have a very high field, a low field, and a low field. It's great, except if you have a very high field, you can't be applying any phosphorus to that field, from fertilizer or manure. So if you have fields that are very high, you need to go back and figure out what you can do management-wise to be able to get that level, hopefully down to high or medium, depending on what strategy you use. Okay. The other form or report that is important for you to look at, I mean, they're all important, but this one I want you to look at today is the Farm Nutrient Balance Report, okay? This is another regulatory requirement. And what this report tells us is if you have enough land base, okay, for the manure that you're producing on your farm. So you can see to the left here, it shows every field, it shows the crop you're growing and the acreage and the yields, okay, that you have put in there. And then it tells you, based on this information, the nutrients, total nutrients that will be removed from that field, okay, when you harvest. So that's the removal by crops. So with the crops that I'm growing on the acreage that I have in here, I'm removing 9,000 pounds of nitrogen, 4,000 pounds of phosphorus, and 11,000 pounds of potassium. All right. So then it takes the amount of manure that's being produced on the farm. So you put in a volume, 1.3 million gallons. And with that volume, there were nutrients associated with that, right? So how many pounds of phosphorus from manure are you producing on your farm? Nitrogen and potassium. So you can see here, I'm producing 36,000 pounds of nitrogen, producing almost 12,000 pounds of phosphorus. And then it simply subtracts these numbers, okay? If you get a negative number here, it means that you have more nutrients than your land base can handle based on the crops that you're growing and the yields. So I have a negative number here. It's saying I don't have enough manure or I don't have enough land. And this is something that has to be reconciled in your plan, okay? And hopefully nobody's in this situation, but if you are, you need to work with your technical service provider to figure out what you can do. And this may mean exporting manure off the farm, may mean you need more land, but hopefully everybody is in the positive here. It's fairly rare to see anything like this. Okay. You can see there's a number of other reports here. They'll all get printed out when you do the combined report, but the big three that I want you to look at again is the manure drawdown. Want to be looking at the P-index and the farm nutrient balance. Okay, so you got to make sure you've drawn the manure down to near zero. You need to make sure that you have your imbalance, nutrients produced versus nutrients removed, and that the P-index, is calculating, but also if you have high, medium, or very high fields that you're meeting the regulatory requirements around those. All right, so let's talk about that a little bit. Okay, so last week I had you go in and your homework was to enter the manure applications, enter the fertilizer, just get that in, right? put in what you normally do. And so let's go to a field here. Okay, so you put in your manure applications, you put in your fertilizer, and then you could see the balance here. You know, were you adding more than what the soil test said? Were you adding less than what the soil test said? How close were you? Okay. Now, if you scroll down here, you can also see the phosphorus levels, nitrogen leaching index, and the Vermont P index. So remember, with the Vermont P index, there are regulatory requirements around medium, high, and very high interpretations. So if you're in one of those ranges, you need to make sure that what you're doing above here meets those requirements. So I have a very high P index. And the requirement around that, the regulatory requirement is, if you have a very high P index, you can no longer add phosphorus in the form of manure or fertilizer to that field. And you have to have a drawdown strategy. So basically, how are you going to get the soil test levels low? Okay. Now, in this case, the soil test levels are already low. All right. So I'm not going to try to draw down those levels. I am, in this case, able, because the levels are low, you are able to apply to the soil test level, but not above that. Okay. So let's go up and see what's going on here. All right, well, I've over applied phosphorus by 96 pounds, it says. I put on 161 pounds and I only needed 64, okay? So with a very high P index and a phosphorus requirement from the soil test, I can put on 64 pounds of phosphorus. Okay, but I can't put on any more than that. And so I need to figure out what I'm going to do here. And really the probably primary thing is I need to reduce one of these manure applications. So I put manure on in November of 2023. Well, I can't go back. I can't take that back, right? But I can probably remove I can probably remove the April one. I don't really need to do that. So I'm going to take that off. Okay. Right. All right. So I took that one off and I'm still over. So, you know, I'm over by 40 pounds. Now, the fact of the matter is that I can't change what I did already, but what I can change is this fall's application, right? So I put on manure last November and I got 100 pounds of phosphorus. So I need to make sure going forward that I'm only putting on 64 pounds, no more than that, right? So I need to reduce my fall rate. So this November, I'm going to go in and I'm going to put on 15 tons instead of 20. Update. Hey. Just get that again. Oh, sorry. Here. All right, so I changed that for this coming November. And you can't really see it because we're not accounting for it yet. But you know, last November you did the same thing of 100 pounds and that was too much, or 20 tons and that was too much. So you need to cut that rate down, right? So your goal today is to go to each field, make sure you're meeting the regulatory requirements, okay? Especially related to the phosphorus index. So if you have a medium, a high, or a very high P index, you need to make sure that you're not applying too much phosphorus. And in the case of medium and high, you can only apply to crop removal rate. Okay? So you can apply, if you're medium or high, first you can apply to the soil test level, which in this case is 64 pounds. And I'm over applying, right? So if you have a medium or high P index, you can actually apply to crop removal. So what is crop removal? You hit this button, okay? It will show you the crop removal rate, okay? And so at this point, I'm over still by 45 pounds, right? So you can use these tools to get yourself into the range that you need to be to meet the regulatory requirement. So today, while you'll have quite a bit of time now, you want to go back, go into each field, okay, and make sure that you're meeting the P index requirements, and that your reports are populating, and that the manure has been drawn down, and that you're showing that you have enough land for the manure that you're being produced. And for most people, this shouldn't be a huge, hopefully not a huge undertaking. Hopefully you've already done that all along the way. And if that's the case, you can print or produce a combined report and email that on to me, and I will review it and be ready to give it back next week. I think there's one more thing I should probably mention. Go to the field by the river. Get out of the other one. Okay. The one thing also I want to mention is that you cannot, based on the regulatory requirements, you cannot add, you cannot over apply nitrogen. Okay, so if you're applying fertilizer and the soil test says you need 150 pounds, but you feel like your crops need more and you always put on more, then when you do that, so here, I'm gonna do an example here. Okay. So I put on what I normally use, which is 230 pounds of nitrogen. So you can see I've over applied by 80 pounds. Okay. Now, how the state views this as an over application, and it's not allowed. Okay. So just because this is just nitrogen, you're still not allowed to over apply above the soil test recommendation. So you have a 10%, something about this 10% either way. So you can over apply or under apply. Well, over apply is what they're looking at, by no more than 10%. Okay, so in this case, you could put on 15 more pounds and that would be fine, but you can't put on 80 more pounds, right? The state will not allow that. That is part of the regulatory requirement. So be checking the phosphorus index and also checking any overages on your nitrogen levels as well. Okay, so if you get through all that, like I said, if you go to your NMP and you hit combined report, I don't know if this will actually work. I think it will. It should produce all the forms together in one PDF. And when you're ready and think you're done, go and try to do that. And if you actually get, oh, we did a combined report, peruse through it, make sure everything looks good, and then you can send it to me. Here's all the reports. And I will review it and bring it back to you next week. Okay. We'll also be reviewing plans next week for other people too that may, you know, if you don't get them completed today. All right, well, I think that's everything for today. I will stay on here for a little bit if anybody has questions of me, but otherwise, I think, you know, it's time to get those plans finished.